So we talked about the Azure Event Hubs, right? The event processing. Basically, that's becoming more popular architecture style with the microservices. Okay, so these are the two patterns you can call which are becoming more popular today. One is the microservices, and the other is the event based processing, event driven processing. Okay, so mostly when you have in database or files, they are like batch processing, and then it's time based, not event based. So, for example, I schedule my jobs to run every 1 hour or daily updates we get, right? And then files, somebody pushes the files into some storage FTP folder, SFTP folder, or into a S3 storage location, or into a ADLS location, Azure Data Storage location, wherever it is. It's a time based, right? So, and then we run it. Event based is like something happened and immediately that event is triggered and then published. So somebody is publishing the events to you and you are consuming and then you are processing. Okay, so initially there was a middleware, like few years ago the architecture style was synchronous or a middleware. There was a bus in the middle, and then there was an event published and somebody is subscribed is already reading it. So the event, the publish and subscriber was closely connected. So the publish and subscribe have a handshake. The moment they publish, you should consume. Until you consume, it will be waiting. So it was that kind of closely coupled pattern. Okay, earlier. Um, Basically, like, there was so many issues, right? So first thing is consumer and producer are tightly coupled. You cannot have multiple consumers. The same consumer has to update. If 10 people want the same data, the same consumer has to go and write to 10 different places. Second, there is no fault tolerance. If there is a failure, if the data errored out or server is down, the consumer is errored out, you lose the messages. Okay, the kind of thing. And again, the same thing from producer. So you cannot have multiple producers producing, sending the same event, kind of a thing. For example, if there is a event called customer, right? And customer, whenever you get a new customer, you are publishing the topic. But what happens if it is non-standard? Say producers from clients, different clients are sending the customer event to you, and then they all have different systems. Now they can define their own definition of the customer. Somebody might send the first name and last name in the customer. Somebody might send last name plus first name in the thing. Somebody might miss the last name and send only the first name. Somebody might say full name, something like that. And everybody has different definition of what they send. But now they can send it to different topics. But if you want to standardize, customer is the same topic across all events, so everybody can publish to the same topic. So all of these things were addressed when we moved from the bus middleware bus system, pub sub system to hub and spoke model. Okay, hub and spoke model is like producer and consumer model. So that's what we're talking about today in today's session called Apache Kafka. So basically, what we learned, Azure Event Hubs is also closely integrated or native to Kafka. Same publish and subscribe. Even Kafka can write or publish to the event hubs, and Kafka can also read from the event hubs as a consumer, kind of a thing. Um, so these both are very closely connected. Okay. Now let me share my screen and then we will talk about the Kafka system. Okay, Apache Kafka. So how many of you have heard of Kafka or Okay, let me ask, how many of you heard about Kafka?
I heard about it.
Yeah,
I
even
heard
me.
it. I've heard about it, but I haven't used it yet.
Okay. So where did it go? Okay, who all heard Ramya, Nabi, and Rahul? Okay.
Yes.
Even me, I have heard this.
Okay. All right. So do you know who developed this Kafka? Who invented or developed this?
I guess it's LinkedIn.
Huh? Okay, I can't hear.
LinkedIn.
It's Apache.
LinkedIn.
No, who's? I think I can't hear you. Somebody was talking earlier. Narasimha or Rahul? Who's that? Somebody was saying earlier who created this.
It was me. Is it LinkedIn?
Yeah, right. So Kafka was created by LinkedIn. It's their product. See, most of the products we know have been originated from this top five, 6 companies. They created first for their internal usage, and then they open sourced it. Okay, so it's interesting. So LinkedIn created the Kafka, and then they open sourced it for the Apache project. So it became Apache Kafka open source project. Same like Databricks, or it's not Databricks. Yeah, the guys who created in UC Berkeley Apache Spark. Now they went in and created the company called Databricks, and then they own but Apache Spark is open source, but still they have like they maintain and provide updates and productized package and product and support and all of that, and they built a lot of ecosystem around it. But the central engine is that. So that's from the Databricks. Airflow, Airflow. So I think that's created by Airbnb. So they created the Airflow product, and then they have open sourced it, right? I think Netflix also created something product. So many of these companies, they created products in-house for their usage, and then they kind of open sourced it for everybody to use. So similarly, Kafka is created by folks LinkedIn, but now it is maintained by a company called Confluent. I think the same inventors, they formed a new company called Confluent, and they are now supporting that and maintaining and enhancing the Kafka. So it's called Confluent Kafka. Okay. So what is Kafka? Basically, it's a distributed event streaming platform for high throughput real-time data processing. Okay. It's a distributed. So you have to look at the keywords. So distributed is one keyword. Streaming platform, real-time data processing, and high throughput. So these are the important keywords that you should talk about. We'll talk about what each of those mean. Used for message brokering, stream processing, and event-driven applications. So that's what we're talking about: event-driven, stream processing, and message brokering. It was originally developed by LinkedIn in 2010 to handle real-time data streaming and log processing. Later open sourced and became part of Apache Software Foundation in 2011. Now it is maintained by Kafka community with significant contributions from Confluent, which is a company founded by original creators of Kafka, these guys. Okay. Why use Kafka? Because of its scalability, fault tolerance, durability, high availability, all of those features that it gives, right? And then use cases. I'm not able to see that. Okay. What are the use cases? What's happening to this? Okay, log aggregation, real-time analytics, event-driven architectures, and microservices. I was talking about microservices, event-driven architectures, and real-time analytics are the common use cases of the Apache Kafka. Okay. Now look at this architecture. So most of this we already talked about when we talked about the event hubs also. So you should be able to relate some of it. Then let's look at it. What did we talk about the sources? We have databases here, IoT, Internet of Things, like sensors that stream the sensor data. Point of sale, which is your point of sale is called your physical stores where you buy, right? So those are point of sale. EMR, elastic map reduce. This is AWS thing, forget about it. Or any of other sources like S3 or whatever, your APIs, your triggers, whatever that is sending data and have this producer. Remember, we said we have a producer, right? Producer is something that produces the messages. This producer will take this message, read this message, and publish to Kafka. Okay. So this box here is a Kafka. So it has a schema registry where it will maintain what is the schema of all of these things, metadata. But this is the Kafka cluster. So this is entire Confluent Cloud. So what does the cluster has? Kafka cluster. It has a broker. A broker. And inside the broker, you have partition. So what is the broker? In its simple term, broker is just a server or a machine. Okay. Where processing happens and storage happens. It's just a box. It's just a machine, computer. Okay. So it's called a broker. Why is it called cluster? Because it will have multiple brokers all connected together, and it's called a cluster. Okay. So you know clusters? I think most of you, everybody knows what a cluster is, right? Cluster is just collection of machines connected together and working together. So you can have more processing power. You can distribute the work to all the machines. So you have broker. Here we have 3 brokers. You can have 1 broker. You can have 2, 3, 4, 5. You can have as many as possible, but minimum is 1. At least have 1 broker. Within the broker, you'll have partitions. So how are these partitions related to, we said, topics, right? So topic 1, we said customer. Topic 2 is address. Topic 3 is phone or email, whatever it is. So this topic, we said we can have multiple partitions. So those partitions actually live in these brokers. One partition here, one partition here, one partition here. And then you can have topic, partition here, partition here, partition here, topic 3, one partition, one partition, one partition. Now, closely observe the partition numbers and tell me if what you see, if there is anything that you notice. In 3 brokers, you have partitions. Pick any partition and closely observe.
Some of the partitions are present in multiple servers. Like topic 1 has 2 partition 1 and partition 2. So partition 1 exists in both broker 1 and broker 2.
Oh, good. So basically, it's not present, it's duplicate. Okay. So the same partition is replicated, rather, not duplicate. We say replicated. Because I said right yesterday, fault tolerance. What happens suddenly if broker 1 fails or goes down, right? It crashes. Then what is your backup? So backup is your broker 2. Okay. So then it will say, hey, there will be a master, or they will, within the brokers, one of them will be master and other slaves. So then it will say, hey, if one broker machine or one slave is down, where can I get all that information from? So that is from the schema registry metadata. It will store, the master will store all the metadata of, hey, this is the topic 1. It has 4 partitions. Partition 1 and partition 2 are in this machine, 3 in this machine, 4 is in this machine, and the copy of this is in these machines. So basically, each partition can have a replica or replication factor also you can choose. You want to replicate 2 times or 3 times. So each partition then will be replicated 2 times or 3 times. So each message you send will be written to this partition in all the machines. So that way you have always backup copies. So if one broker goes down, you cannot, the other brokers can always provide, the Kafka can read, consumer can read from other partition, other brokers, basically the same data. So if broker 1 goes down, partition 1 is in broker 2, it can take from here. So this 0 and 2 are not there here, okay? But it might be in some other broker which is not represented here, or topic 2 is not replicated maybe, okay? So there is no replication factor, 0, 1, 2, so it does not have a backup. Topic 3, partition 0, partition 2, which I said, there will always be some replication factor. They might be represented in other brokers, not here. But the point is, topic. So first thing, your producer will read from the source. It will publish to Kafka. Kafka cluster is a collection of broker machines where your messages are stored. How is the message stored? In the form of topic. So message should always have a structure or a label, right? What that message is conveying. What is the structure, or what is the information that message is having, right? So that information is called a topic. You will give a topic name of the topic. So that topic, that message will go to that topic, and topic basically has multiple partitions which is distributed across brokers. So it can write to any of the partition for that topic. Okay. So this is how the publisher side of it works. Then you have a consumer, right? So we talked about consumer group, and the consumers within the group. So these consumers will read the topic. These are registered to a particular topic, and they read messages coming into that topic in any of these partitions, all the partitions, based on the number of consumers and in the broker. So there is something called a zookeeper. Basically, I think it is now removed. Earlier, they used to have a separate machine or separate component called zookeeper. The functionality of the zookeeper is like only to maintain the watermarks, which consumer has read from which topic up to which point. So all of that metadata was stored in the zookeeper. And also which is the master, which is the slave machines, all of that communication. Basically, it's kind of a metadata which will have all the information about the cluster. What topics, how many partitions, where are the replica on which machines, which is the master, which is the slave, which consumers are reading, up to which point they have read. So all that information, earlier it was there, but now I think it's moved back to the internal processing. Ecosystem, basically the next 2 slides talk about what we have already seen in the architecture here. There are some more, maybe more detailed components we can talk about, but the high level, I think this is good enough for us to get started to understand the basic concepts of the topics and broker topic partitions with this. So what do you have in the ecosystem? Producers, they publish messages to Kafka topics, right? Brokers are Kafka servers that store and manage messages. Topics and partitions. Basically, messages are categorized into topics and stored in partitions for parallel processing. This is what we talked about. Why we have different partitions? Because we can do parallel processing. We talked about it in the last class in the event hubs, right? Same thing. If 3 messages are coming in, if they are written to one partition, so only one consumer can read one by one from a consumer group. But if they are written into 3 partitions, then I create a consumer group with 3 consumers. All 3 of them can go and read one from each partition. So 3 messages can be processed in parallel. So that's why we have partitions, or I think it's called logs also. Topics and partitions. Consumers subscribe to topics and consume messages. Zookeeper manages cluster metadata, leader election, and configuration. Sorry, it's not called master, it's called a leader here. So different clusters have different names. The Spark clusters have master and worker. Some of them have master and slave. So here it is called leader. Master is called leader here. So that zookeeper that manages the metadata of the cluster. Basically, what are the producers, what are the brokers, what topics, what partitions, which consumers have read till what point, watermark, and all of that. And then leader, which is the leader among this. All of this is the maintained in the zookeeper and configurations. Again, same thing in detail, topics and partitions, logical categories for messages. Example is like orders. Order is one topic. Customer can be one topic. Address can be one topic, right? Account can be one topic, right? And transaction, bank transaction can be one topic, something like that. So user events. Partitions are distributed segments of a topic that allow parallel processing. So basically, if there are 100 orders coming in for the topic, orders topic, and somebody is publishing 100 orders, and if orders has say 10 partitions, so 100 orders will be distributed in the in 10 partitions, almost in the round robin fashion, equally. May not be exactly equal, but almost similar. So each partition has close to 10, 8, 9, 10, 12 kind of messages or written messages written to those partitions. And then consumers can read parallelly from them, or if they have one consumer, it can read from all partitions. Producers publish data to Kafka topics. So these are topics and partitions. Producer will publish the data. They can send messages synchronously or asynchronously. So basically, synchronous and asynchronous is, synchronous means they publish the message and wait for a confirmation. Okay. That the message is delivered from Kafka. Kafka will send in some confirmation. So that is called synchronous. Asynchronous is fire and forget. You just send the message. I don't care whether you received or not received, you saved or not saved. My job is done. I have sent it, kind of asynchronous. Okay. Here, partitioning strategy can be round robin or key based. So basically, when I talk about partitions here, right, that it will distribute to all the partitions. So there are different strategies. So one is round robin, where you don't want to control anything. So it will go in round robin fashion. It will go first message, it will put in partition 1, then 2, 3, 4, then come back to 1, then 2, 3, 4, something like that. Okay. Or you can do key based, so which you can control. So when you send a message, you will send a key of which partition it should go to. So it will go and write to that partition. So this is how you can control which partitions you want to write. It's available if you want to use the strategy. Brokers are like Kafka servers that store data, handle message storage, replication, and retrieval. And there is also something called retention period. So your messages will be stored in the servers for all the consumers to read for a particular time. So that you don't want it as a database ultimately, right? It's a temporary storage. You want it as a temporary storage of messages until all consumers read the data from the servers, from the Kafka. It can be 1 day, it can be 3 days, or it can be 7 days, depending on how much data you have coming in and how much space you want to put in the servers. But it is not indefinite, because again, you will process and write it into database somewhere, right? So why do you want to use Kafka as a database? It will become a database if you leave it unlimited. So you have to make sure, but at the same time, consumers can fail, can restart, can read. There will be a lead time. They want to reprocess. They don't want to lose data. So at least you can put 3 to 7 days of data retention in the consumers. So after that period, it can delete the data, the older messages. Consumers and consumer groups. Consumers pull messages from Kafka topics that we know. Consumer groups allow parallel processing. So one group, if it has multiple consumers, they can parallelly read from multiple partitions of the topic. Zookeeper handles metadata leader election configuration. Now it is being replaced by KRaft, Kafka Raft metadata mode, for better scalability. I don't have much information about it, but you can look it up. KRaft, but earlier it was like, it is in newer versions, but earlier versions had Zookeeper. Now, these are the more basic terminology when you talk about Kafka components, and this is all the functionality it is. So everybody is clear?
Yes, sir.
Guys,
Yes,
come on,
sir.
speak up.
Yes, sir.
Okay. You will all be giving demo on this and event hubs. You have to choose 3 of you on event hubs and 3 of you on Kafka. Okay, this weekend on Sunday. So you have to prepare same thing like you did last time. So you have to prepare those demos and deliver. Half of you on the using Kafka and half of you using event hubs. So be prepared. Pay attention, and if you have any questions, let me know. It's not like come sit and go. Okay, pay attention. Now, how is Kafka in modern data engineering pipeline? So this is fine, messaging thing, but our focus is on the data engineering, right? So that's what we are focused on being here. How do we use all of these tools in a data engineering platform? So in big data and cloud platforms, this Apache Spark or Apache Flink, we can integrate with for stream processing. AWS MSK, Azure Event Hubs, Google PubSub for managed Kafka services. Okay, so Kafka can be integrated with Event Hubs also, or Google PubSub for managed Kafka services, or you can directly read from Apache Spark as stream processing. Or see, it's like, plumbing, right? You can keep connecting pipes with the joints, T joints, okay, L joint, T joint, whatever it is. You connect Kafka to Spark, stream directly reading, or you split it up, put event hubs in between, from Kafka to event hub, and then event hub to Spark, Apache Spark you can read, or directly without Kafka, event hubs, Spark streaming, like last class we did event hubs to Spark streaming. Now we will do Kafka to Spark stream. Okay. Databricks and Snowflake for data lake integration. It's the same thing. Spark, basically what they're saying here, Spark is even without Databricks also you can do Spark, right? You can write a PySpark. It's an open source. You can just import the Spark library and then write PySpark program anywhere. Even if you have your own cluster and create your own Spark program to run the program. So same, but with Databricks also you can do, and Snowflake also you can connect to the Kafka. So Kafka streaming with Spark structured streaming, real-time data processing for fraud detection, IoT analytics, or stock market insights. So these are the examples. That's it. Okay, those are the concepts. Now, questions.
In the diagram, right, architecture diagram, what is the schema registry does? Can you just
This one?
schema registry and then to connection API?
Yeah, so these are, see, alternate ones, right? So you can connect API source connectors. So Confluent, Kafka will give you their own connectors. You can directly read, they can directly read from a source and push to broker instead of you writing producers. And then sync, they have predetermined sync connectors. Let's say if I use Kafka sync for Postgres or Kafka sync for Oracle. So if you connect them, it will automatically read topics and then put it to target database. So those metadata will be put in the schema registry when you use that.
Okay.
Okay. All right. Yeah. Any other questions? No? Oh. So let's get into hands-on demo, right? So what I'm going to do in the demo is first we will go and do the without Databricks using Python. We will write some producers and consumers. Okay. Then we will go and connect it with the Databricks. So to do that, first we need to have, what do we need to have first? Tell me for the demo. Come on, guys, talk. It's okay.
Need data sources, right?
Okay, data sources. I will write some own messages. Then what else? Just the data source is enough.
Producer API, yeah.
Okay, you will read. Then what you will do with the message?
When the message will come, it will come into the encrypted mode. You will have to do the decryption.
No, we are not going. We are going on onto the other side. So first, I only have a source. Nabi said source. I have a source. Then what?
Need to create the producer,
Okay, good. Yeah, we need to do a producer.
then
Then
create
what?
the Kafka cluster, like by using a
Exactly. So
broker.
we need.
Session, yeah.
Oh, we need a Kafka cluster, right? First.
Yeah.
Where is Kafka? Where is Kafka cluster? So Kafka cluster.
It is inbuilt, provided in the Azure Event Hub.
No, that is event hubs, not Kafka.
Yeah.
Okay. So Kafka is a separate thing that I talked about, right? Confluent. So you can create a in the cloud. So just like you are doing all the like Databricks Community Edition, right? Similarly, Confluent will give you a free tier Kafka to use. So first you have to create a Kafka cluster. You go here. Okay, go to Confluent, confluent.com, and then sign in. You can go ahead and create a Kafka cluster for yourself. It will go here. And then it will give you an option to create a Kafka cluster. So you can go and create the Kafka cluster here. So this is the cluster. I have one running cluster. So default I've created. So what it will show is, see, overview. In this, there are 6 partitions. Okay. and one topic I have created. Topic is called movies. And there are 6 partitions I've created. There are no connectors, no case equal DB cluster. So this is my cluster. Okay. Now, what is the type is available over the public internet, this cluster. These are the IPs used for the server. Okay. IPs used by clients and applications to connect to the Confluent Cloud cluster, ingress IPs. Okay. Now, what are the cluster settings? Name. So name of the cluster is this. This is the cluster ID. So if you see, these are the cluster details. Endpoints. So this is the endpoint. Your Bootstrap server. This is your REST endpoint. If you want to use it as an API, so you can use the REST endpoint. Okay. And this is the Bootstrap server, or you can say your broker address. Right. And then you have your API keys. So you go and create an API key. So these are all the basic settings. It will be very intuitive. You can go create your login, free login, and then create a cluster, free cluster. And then automatically it will give you all of those details. You don't have to go and do anything. Just create the default cluster, whatever it by the default configuration, and then go and add a API key. Just one key you need. You don't need to just create one key, and then store that key details, because you will need it to connect to the cluster. So you can go and create topics here. So you can do a topic name, okay, and partitions. So you can go and create your own topic name and give the partitions. How many partitions? So default is 6. So how many you can give partitions? So this is enable infinite retention. See, if you put this, your data will be always there. It will never get deleted until you go and delete, or it will just keep building up. And then cleanup policy, see here, delete storage 1 week. Retention time is 1 week. Size is infinite. You forget about it. This size means a partition can grow before it is discarded to free up space. So if we give this, it will give, so each partition can be only up to this size. If it goes beyond that, it will be discarded, it will be removed or deleted. Retention time is 1 week. After 1 week, you will lose all the messages. The replication factor we talked about, see here, it has a 3. So each partition is replicated 3 times. For redundancy, topics configured for an optimal balance of performance, durability, and redundancy. So this setting is locked. So it is locked as replication factor as 3. Minimum in sync replicas 2. So at any point of time, 2 replicas should be always in sync. So this is the cluster. Okay. So go here, create your environment. You have a Kafka cluster. Now what you need to get to run this, right? As usual, go to Google Colab. We have done earlier, right? Using S3, we connected from Google Colab. So you can open a Google Colab and then install this pip install Confluent Kafka 2.3.0 greater than equal to 230. This library, go and install. Let's run this. Okay. And then from that library, I'm importing producer and consumer classes. Okay, so it will default give you some classes which you can use. to create a producer and consumer. When you go to cluster, just go and set up, say click on get started. Okay, clients, set up new client. So here it will give you your language. So it will give you some automatic, the boilerplate code that you can use to connect. So you can have this select Python. Then you can say API key. Remember the other day, just before I showed you the API key that you need to generate. So get that key and secret here. Then you select a topic and then you click download. Okay. So when you do download, you will get a folder or a zip file. Let me show you like this. C Cloud Python client. Okay. So you will get this. Inside this, you have a Python file. You have a client properties. You have requirements.txt. So you don't need this requirements because I have already added that here directly. So you don't need the requirements file. So client.py, it's the same code that I have copied here. Okay. Then there is properties. Okay. So you have to add this properties file. So client.properties file, because it has all those your keys and structure, everything in this file. When you download from there, it will give you the properties file with all the required configuration. So if you open this, you will see your Bootstrap server. That is your server name that you have to connect to. What is the protocol mechanism? What is the username? What is the password? Session timeout, client ID, everything will be there. So just take this file. What do you mean by file? This file client.properties. You just go here. This is the folder, right? Upload this file. Where is that file, man? C Cloud. Yeah. So go here and upload this client.properties file. So then you can read that file here. So what I'm doing, first read config, open client.properties. So this is all Python code. For each line in the file, line.strip, I'm checking if it is not, length is not equal to 0, which means it is not an empty blank line, or it is not a comment, which it starts with hash, right? So if it is not commented and it's not a blank line, then I am splitting that by equal to, right? So if you look at properties file, it is key value pairs split by equal to. So before the equal to, bootstrap.servers is key and this is the value, entire thing. So that's how I am splitting that and putting it in parameter and value and adding it to a config dictionary, parameter equal to value. Okay, so this is called a dictionary. So if you print that, so let me run this. Let me first show you. Clear output. Now I will run this. So here you get all your properties. Bootstrap servers is this, security protocol, mechanism, password, blah, 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 everything. Next, from the library, since I have installed the Confluent Kafka, I take a producer and consumer. Why am I doing this again? It's okay. This is a read config. Same thing. Produce topic and configuration. So this is, I'm creating an object called producer with the configuration dictionary properties, which has all the connection details and everything. And I'm passing a topic, which topic I want to write the message to. So what message I want to write? I'm just sending a simple JSON file. So what is the simple JSON file? Remember earlier we had, I think we have here simple JSON file.
Hey Harun, I have a question.
Yeah,
Why are we doing with Google Colab this time? Why can't we directly do it in Databricks?
we will do it. So data engineering is not always Databricks, right? Tomorrow you may not have a Databricks. If you just want to publish, so let's say you have an Oracle database and somebody gave you a job saying that, hey, all the messages every day you write a job to write it to the Kafka. So you cannot tell them I need a Databricks environment, right? So not everybody will have Databricks.
Okay.
Correct. So
Yeah.
basically, you should understand the mechanism of how you are connecting to Kafka. Whether you can connect from Databricks, you can connect directly, just like Python code. You can connect from Java. You can connect from Rust. You can connect from any language, right? You can basically write a producer and consumer in any of the supporting languages. Correct. So that's what I'm
Yeah.
showing.
So same thing for Event Hub also, we can do it from Google Colab.
Yes, you can.
Okay.
It will support. I haven't tried it, but you can try. See, Databricks is also same thing, right? Databricks is also Python code only we are writing. The same code you take out of Python, out of Databricks notebook and put it in a Google Colab Python notebook. There
Okay.
is nothing.
Okay.
The Spark we are using Databricks to process that data, what we are getting, and then write to tables. If you use in Google Colab, you can connect and see the messages, but you cannot write it to anywhere unless again from Python you have to connect to a database. Some database you have to connect to and then write.
Okay. Okay. Yeah.
Right?
So Databricks is just a kind of environment which is providing us both the things, like we
Yes,
can
yeah,
go and see the database as well.
exactly. You can
Okay.
go and read from the source. You can do the processing and then you can also write to databases. So the end-to-end platform. Okay. But the
Yeah.
central core, you are again using Python and Spark. Okay. Spark is for faster processing, distributed processing that Databricks provides. And it gives data frame so you can easily just write it to table. If you take that out of the equation, if you just use Python, it's all like you are doing all the job. So you read all the message, you create a JDBC connection to some database, then you get the table name, you format everything, and then split it into batches, then trigger a insert statement into the tables. So all of that you have to do it yourself, which if you use Databricks platform, you just say data frame.write. So everything it will take care of,
Okay.
right? So that's the advantage of the platform. Okay. Where are we? Sorry, I was trying to show you data engineering. Put all the files in one place. I'm very bad at organizing things. Data engineering training. Yeah. Okay. So this is simple JSON. You can see. Yeah. So these are the messages I'm trying to publish. Okay. Let's say these are the messages I have as a source. Now my producer will read the source and then publish to Kafka. Right? That's
Yes, sir.
the
Yes,
pipeline.
yes.
Right. So that's what we're trying to write here. So I'm creating a producer object using the producer library with the configuration, giving it where it needs to connect the servers and authentication and everything. Now I am reading simple JSON file, which means that I have to again add that file here. Otherwise, it will not find the file, right? So go here. Here. And data engineering source files, simple JSON. Okay, so that file also I have added client.properties and simple JSON. So client.properties is coming from your Confluent cloud, Kafka, where you created your cluster, all configuration, you download that, you get the properties file. This is your source file. What I'm doing, I'm taking a same JSON file, having a counter here per line in this key value is my just number 1 2 3 4 numbers. Value is this message. Okay, this entire name, age, city. So this is the message that we have. That is the key. This is the value. Now producer dot produce to this topic. This is the key and this is the value. Okay. Then it will print that, okay, I have already published the message to topic. And then I'm incrementing the counter. Okay. So, and send any outstanding or buffered messages. If there is anything, we will flush. Similarly, I'm also creating a consumer. Okay. Consumer group, set the consumer group ID and offset. So group.id is Python group 1. Okay. So I can just say movies group 1. Auto offset reset. See, I am reading from the earliest message that I have. Consumer I created, again pass the config. Subscribe to the topic. So here, see, it is an array. You can subscribe to multiple topics. Same consumer can read from multiple topics if you want. You can subscribe to multiple topics, but which topic you are reading from, the same key and value you have to decrypt. So message equal to consumer.poll. So it is polling every 1 second. If the message is not none, which means message is not null and there is no error, there's no error, then you get message dot key and then decode to UTF-8 because it will be in the encrypted format. So value is message dot value dot decode UTF-8 and then print the consumed message from topic. Okay. So this is your consumer. Now I can do config, read config. Topic is I'm adding topic here movies. Now I'm calling produce with movies and consume with movies. So if I just take this here, So let's run the program. So we have done the read config. This is done. So I will just run these methods. Okay. All of these. Now, first I will start the consumer. It will start looking to the cluster and see if there are any messages. So I will start my consumer. So this has already existing messages. It has read earlier. Okay. How many? 1, 2, 3, 4, 5, 6, 3, 2, 2, 1, 1. Okay. So 1, 2, 3, 6 messages. This is a different thing, key value thing. So 1, 1, 2, 2, 3, 3. There are 6 messages it has read. Now we have to figure out where these 6 messages have come from, right? We have let's go here, cluster, topics, messages. See how many messages are there total in this topic?
Total there are 7 messages.
7 messages, right? Now what are those messages? If you see here, key is one name. So we have written twice. So 1, 1, 2, 5 messages shown, 7 messages shown. So one message, it has key as just key, value as value. And other things we I tried twice, published the messages. So since the retention is 1 week, so till 1 week, all of this will be there. Now, that's what the consumer has read from the earliest. Now what I will do, I will go and so I will publish again 3 messages using the producer. So the moment I run this, it should produce 3 messages and it should read the additional 3 messages. It's not allowing because it's the same thread. It's not, it's still skewed. Stop this. Okay, now it has run. Okay, so it produced 3 messages. Now if I run this, we got the latest 3. Because we said we already read the 7 messages. So we're getting the latest 3 messages. Now to differentiate this, we can go and change this one. So I will change the cities here. Say Dallas, Seattle and Chicago. Okay. Just save this. Go back here. Upload the file again. Simple JSON. Now produce. So we got Dallas, Seattle, Chicago here. Go and read. See, now you get Dallas, Seattle, and Chicago. It has read 3 messages from that. And it's continuously polling for any new messages that come in. So if we create another thread and publish from another, because it is a single thread, it is not allowing others to execute since this cell is already executing, but you can do that. But you understand the concept, right? Any questions? I guess, there will be some questions. It would be Confluent, Kafka, but it is very easy. It's just like creating a Google account, new Google email account. Just go click, create, add, sign up with your thing. If they ask card details, you can give, but you can, do basic cluster, free cluster that they give and default configurations. Okay. So that's about the Kafka thing. Now, how do we run that using Databricks, PySpark, right? So it is same. I will start this, but I'm not sure if we are able to complete. We'll continue this. So let me know, guys, if you are feeling this overwhelmed or is this okay? Are you able to follow?
Yeah, yes, sir.
Yes, sir.
Okay.
Yes.
So the same thing, if you are using a Databricks, right? So most of the code will remain same, but that is Python. We'll make changes where we need for the database. So first thing is the library. We have to install the same library here. And then I have split all the configuration properties and added here. Kafka Bootstrap servers, Kafka topic is this. Basically, I have added here. I don't think we don't here. Just put it here. Let's fuse here. Then I can delete this. Now, I will directly read from Kafka. Format is Kafka. Remember, last class we said format event hubs when we are reading from event hubs. We had configuration for event hubs. Same configuration, we have to add options here. Bootstrap servers. Let me see if we can go properties. Yeah. So bootstrap.servers. I'm just splitting all of that dictionary here into this and this key value pairs, each option. Subscribe. Subscribe is something we have to give topics in addition to this movies. Security protocol is this. Mechanism is plain. Okay. And then we have to give SASL, JAS config, this thing, plain login module required. Username is this, password is this. Okay. And starting offsets, I'm giving latest. So all of these are options I'm giving. Now, what is the difference between Python and here PySpark Databricks is, so I'm not giving all of that file in a, how you provide the configuration basically. So these are all kind of boilerplate code you say. You will just do once, that's it, okay? And one more thing here is you have to also provide a library since, Python it's not needed, but here it needs a Kafka SASL JAS config. Remember, for the connect to event hubs, when we created compute, we created a library, correct? We said create compute, and then in the libraries, install a new library, Maven, search packages. Here last time we gave Spark event hubs or something. Remember?
Yes, sir.
Or is it something? Azure event hubs or something. Yeah, Azure event hubs. Spark. Yeah. So this is what we gave. COM Microsoft Azure Event Hub Spark. This is what we gave library to connect to the to connect to event hubs. Similarly, for Confluent Kafka also, you have to give some library, this library. Okay. Spark SQL Kafka. Go here. Spark SQL Kafka. Spark SQL Kafka. Select this 0, 1, 0, 2, 1, 2, 3, 5, 5. 0, 1, 0, 2, 1, 2, 3, 3, 0. 3, 3, 0 or 3, 3, 5. Uh, 12. I don't see a 3, 3, 0. But I think it's fine. Yeah, you can select this and see it should work. 3, 5, 5 and then install. So this is the additional step that you need to do for Databricks to install this library to connect. Otherwise, you will get error. When you run this, so you will get some this error. SASL JAS config error says plain login module not found. So you have to implement it. Now, once you do that load, see you will directly get data frame. So in data frame, you are casting the key as string, value as string. Same thing last time we did like from Azure Event Hubs. You are parsing that, converting it to a string. Same thing, you are converting it to string, and then you get the values here. Now, what is the next step once you do this is basically same thing, right? So once you have the JSON, remember, this is a JSON. Now, from here on, it's the same code that you did for parsing the JSON file. So you go and split it up, say this value dot name, value dot age, value dot city, and then you can, cast a string alias. You can give whatever value JSON and then write it into. You can write this as is into a raw format file into the bronze layer, then read, transform, and put it in. So all the rest of the thing is same from here. So how you're getting the data is what is the important thing. Okay. So the next advanced step for you to look at is once you get this is basically what about the consumer groups and parallelism? How do you create that? That you have to research. Spark.read stream initialize. I'm reading this. Okay, so I think we put the test. Let me try this. Earliest. And run. See, once you know the concepts, right? Whether you do in Python, you know in Databricks, you do everywhere, anywhere. You have to be clear of the concepts. See now, earlier we gave latest, right? So it will only read after it has started any messages that are coming in future. But if you put earliest, it will go back and start from zero. Whatever data that is available for that topic, it will start reading from beginning, all the data. Okay. So how many rows it has? 13 rows, right? So it has read 13 rows. We have Chicago, Seattle thing. So Dallas, Seattle, Chicago, all of this. Now it's still running, right? Now what we will do, let's say we are using your Databricks as a consumer, right? Isn't this a consumer or is it a producer?
It's a consumer.
Right? It's a consumer. So this consumer, right? So this is what is our Databricks now, correct? It is consuming data from this as a stream from Kafka cluster. And then database is like your Databricks only delta. If we want, we can just say df.write. So it will write to the target database. Source, we are uploading a file. Source is our file, right? JSON file, simple JSON. We are putting here. Producer is our, what is the producer? Where is our producer? This is our producer. Already. Now what we will do, let's say, we will run the producer from here. My Python client will be my producer that is reading the config file, or it can be S3, whatever. Read it. This Python producer will publish to Kafka. And my Databricks consumer is already running, right? So it will, the moment my Python client produces and publishes the message, my Databricks client consumer should read and display data, right? So that is the streaming, end-to-end streaming use case, correct? So let's try that. So earlier we couldn't do both same here because it's a single thread. It is not allowing while one is running. So now what we will do, we will do produce. So before that, again, let's go and change the data here. Let's say name. Let's just change new cities. What cities we want?
New York.
New York is already there.
Already there.
Los Angeles. Then we will put Austin. Then we will Houston. Okay, so these are the 3 new cities. We changed the data. We want to look at it. Now, I have to go to my Python client. Here, delete this old file. Add the new file. Simple JSON. I will go and clear the output. I will go and clear. This is not needed, but I'm still just doing. So we are only using this as a producer, right? So the moment I run this, my Los Angeles, Austin, and Houston messages should be published, and my consumer is still running. It's still 13 rows. So 3 more rows. It should have 16 when I do that. Okay. And then it should show the new cities here. That's the use case. Let's go back. I run this. So 3 messages, Los Angeles, Austin, Houston published. We go here. We'll wait. How was it reading? See, 16. Los Angeles, Austin, Houston. It has automatically read the data from the Kafka cluster. Okay. So that's the end-to-end use case. Now start connecting dots, your entire end-to-end pipeline of a data engineering. The source we talked about here, again, it is a simple file that we uploaded. So again, this can be your AWS S3. You can read from connect to AWS S3. Remember, we done earlier sessions. You can use to connect that to S3 and read the files from there. Your source can be a database. Your source can be anything, right? So that you are reading. And your consumer is a Python client, producer. Client can be a consumer or producer. Both are clients. Okay. So your producer client is your Python client, which can read from S3 or whatever, and then publishing to Kafka cluster. So Kafka is the Confluent Kafka is our cluster broker and all of that. And topic is movies and the messages are there. Your Databricks client is consumer, which is reading the streaming from Kafka. It's reading the stream and then processing. So this is your consumer. And then from here, you can write to bronze and all rest the same story. Medallion, bronze, silver, gold. You transform data, parse the JSON, transform data, write it to silver, write aggregates, do whatever you can do. So all the tools are there now for you to explore and come up with the use cases for the presentation. Okay. Work. You can work in teams if you want to. But think, imagine, explore. Don't use the simple. Take any data sets. Use S3 as your source. Use Confluent, Kafka. Use Azure Event Hubs. Use Databricks. Use Medallion architecture, and come up with the end-to-end use case. 2 presentations. I'm looking for one using Event Hubs, one using Kafka. The rest of the tools you can choose. You want from S3 or you want from upload files, you want what client, you want what producer, what consumer, anything. So it's up to you guys. And if you're using Event Hub, so I don't want you to use the same files that I have used in the demos. Okay, simple JSON or Hello Taxi. I use different data sets and try it out. If you need more time, yes, we can give you more time, but let's target for Sunday. Okay?
Yes,
Questions?
sure.
You want to do individual or you want to do in teams?
Let me
Think
know.
about it. Yeah, let me know. That's fine. If you want to do individual is also fine. If you want to do team up is also fine. You can team up, work together, have working sessions, figure out things, figure out use cases first. See, it's not technology, right? So the basic thing is when you discuss, come up with a use case, business use case, come up with requirements. That will help you when you talking in an interview. It's not just for me to showcase or do whatever. The same thing you can talk in the interviews as if your real-time project that you have done. So that will help you to whatever you are discussing, whatever you are coding, and whatever you're presenting will help you when you talk in the interviews. That's what will give you the confidence.
I guess then team would be a better choice, so that would be
Yeah,
interactive
it's up
between
to
with
you
and us.
guys. It's open. See, this is not a school, right? I cannot say
Yeah,
you
I
team
get it.
this and you team up with them. So it's up to you guys. You figure out. You want to work in groups. You want to work in teams. You want to work individually. Yeah, even I suggest teams. It's up to you. You want 2 teams or 3 teams. How you want to collaborate. When you want to do a presentation, you can just use the same group to chat, and then come up with some plan.
Sure.
Okay. All right. Let me